Good morning, children. We are discussing our 6th chapter, lines and angles. And in the last class, we discussed about transversal and parallel lines. Okay, when a transversal intersect two parallel lines, there will be different types of angles. Okay, then what is a transversal? Do you know? A transversal means it is a line which intersecting two or more lines at a distinct point. Okay, listen here. We have two lines M and N, and N is another line L. Here we have three lines. Here the line L, it is intersecting the line M and N at two distinct points. Here the line L is intersecting the line M at the point P, and here it is intersecting the line N at the point Q. So here line L intersecting two lines, that is M and N, at two distinct points, that is P and Q. Here L is the transversal. And here we have different types of angles, that is co-interior angles, pair of interior angles on the same side of transversal. Okay, and corresponding angles. Corresponding angles means, suppose this angle is 1, which is the angle corresponding to this angle 1. Suppose I am given name as angle 1, 2, 3, 4, 5, 6, 7, 8. Which is the angle corresponding to angle 3? Can you say? Angle 7. And angle 4 and angle 8, they are corresponding angles. Then 1 and 5, 2 and 6. I told you one shape. Corresponding angles. These two angles are corresponding. Okay, so corresponding angle means you have to think about our F. Okay, then alternate interior angle. Here which are the alternate pair of alternate interior angle? If I am taking the angle 3, which is the alternate angle? 3 and 5, 4 and 6, they are alternate interior angle. Then alternate exterior angle, 1 and 7, 2 and 8. Okay, so in our last class we have discussed these all angles, types of angles. And today we are going to discuss some axioms and theorems related to these angles. I think that all axioms and theorems we already discussed. That is, here we have two lines M and N, and we have a transversal L. And our first axiom means we already discussed two axioms, linear pair axioms, and here we have the third axiom. Okay, that is, here we have two lines M and L, they are parallel, and one transversal L. Okay, and if a transversal intersecting two parallel lines, if a transversal intersecting two parallel lines, then each pair of corresponding angles are equal. Here one pair of corresponding angles, suppose angle here, if I am taking the angle 2, angle corresponding to angle 2 is angle 5. Okay, so here line M parallel to N. Line M is parallel to L. Sorry, line M is parallel to N. And here L is the transversal. Therefore, the corresponding angles, here 2 and 5, they are the corresponding angles. 1 and 8, 4 and 7, 3 and 6, all the corresponding pair of corresponding angles are equal. Okay, that is angle 2 is equal to angle 5. Then angle 3 is equal to angle 6. Angle 1 is equal to angle 8. Angle 4 is equal to angle 7. All the pair of corresponding angles will be equal. So, if a transversal intersecting two parallel lines such that all the corresponding pairs of corresponding angles are equal. Okay, and what will be the next axiom? The converse of this one. Converse of this one means if a transversal intersecting any two lines, okay, the lines are not parallel. Okay, suppose if a transversal intersecting any two lines and such that a pair of corresponding angles equal. Here the lines are for our fourth axiom, lines are not parallel. It is not given that M not parallel to M is not parallel to N. In our first axiom, M is parallel to N. Okay, here it is not given M is parallel to N. Okay, so M and N, any lines, if a transversal intersecting any two lines such that one pair of corresponding angles equal. Suppose here M and N not parallel. Okay, and we need to prove. Then what will be our second axiom? M and N any lines. L is transversal. So, the transversal L is intersecting any two lines such that a pair of corresponding angles equal. Okay, so M and N not parallel, but corresponding angles. Here 3 and suppose I am taking this pair 3 and angle 6. Okay, then the lines will be equal. If the line L is intersecting two lines such that a pair of corresponding angles equal, then the lines will be parallel. Clear? So, if we have two lines and a transversal, okay, and one pair of corresponding angles are equal, therefore these two lines will be parallel. That is our second axiom. I think it is clear. Okay, our first axiom is, it is clearly given that M and N are parallel and L is the transversal. Okay, then if a transversal intersecting any two parallel lines, then the corresponding angles, pair of corresponding angles, all the pairs will be equal. That is our first axiom. Okay, and our second axiom is converse of that. That is, a transversal is intersecting any two lines such that a pair of corresponding angles equal. Corresponding angles is equal, then the lines will be parallel. I think it is clear. Okay. Then, okay, we can take the same figure and it is related to alternate interior angle. It is a theorem. Suppose if line L intersecting, if any line is intersecting two parallel lines, then the alternate interior angles will be equal. Here which are the, first we discussed about corresponding angles. Now alternate interior angles. Here 3 and 8, 4 and 5. These are the alternate interior angle. That is, if a transversal is intersecting two parallel lines, then the alternate interior angles will be equal. Okay, and the next theorem. If a transversal is intersecting any two lines such that a pair of alternate interior angle is equal, then the lines will be parallel. Okay, that is, in the second case, the alternate interior angles are given. It is given. If the alternate interiors are equal, then the lines will be parallel. If the lines are parallel, then the alternate interior angles will be equal. Okay. Then third one. Third theorem means that is about co-interior angle or interior angle on the same side of transversal. That is, if the lines are parallel, then the pair of co-interior angles will be supplementary. That is, here M parallel to N. Then the co-interior angle, that is angle 3 plus angle 5 equal to 180 degree. Then what will be the converse theorem? That is, if the sum of these two angles, that will be given. If the sum of these 3 plus angle 5, it is 180 degree. They are the co-interior angles, that is interior angle on the same side of transversal. Okay. If the sum of these two angles are 180 degree, then the lines will be parallel. Okay. First, the lines are parallel. If these two lines are parallel, then the pair of co-interior angles supplementary. They are supplementary, and if they are supplementary angles, this line will be parallel. I think it is clear. First we discussed about corresponding angles. That is, if the lines are parallel, the corresponding angles will be equal. And if it is given that the corresponding angles are equal, the line will be parallel. So the same about alternate interior angles. If the lines are parallel, alternate interior angles are equal. And if the alternate interior angles are equal, line will be parallel. Then same way we can say about co-interior angle, that is interior angle on the same side of transversal. If the lines are parallel, M parallel to N, then the co-interior angles are supplementary, pair of that is sum of that co-interior angles 180 degree, and if their sum is 180 degree, if the sum of pairs of co-interior angle is 180 degree, then these two lines will be parallel. I think these axioms and theorems are clear. Okay, so you have to prepare a notes about these axioms and theorems. Okay, so first you need to study these all proofs. You don't want to prove these all theorems, you have to study the statement of the theorem. Okay, so that's all for today. Thank you.